All right, Ian Zepp here. I'm going to be doing the Skyfi MCP demo. I'm going to be covering the architecture, the confirmation gate, that's human in the loop, eval harness that was built to test that the tool calls were working properly, coverage as in coverage requirements, and then there's a bonus CLI feature at the end. I'm going to go through this in a second. Before we start, I actually want to kick off some of the agents using pre-set up queries, just to demonstrate that this works behind the scenes. So I have one desktop codex, one terminal Claude code, and one terminal codex as well. The purpose of this project is to add an MCP layer on top of the existing API. We don't want to just make it a generic wrapper. The real question is, can it be useful enough for an agent to run real-world complicated multi-step queries? And I think that was achieved. I'm not going to go through this document. This is available in source code. Instead, I'm going to focus on some of the architecture that was defined. So the core is the MCP loop, obviously. This was implemented to closely mirror the API structure itself, so that the names of the tools were consistent with the names of the API URLs. There is a runtime local, which is bun, that was done to make testing easier. And there's also a Cloudflare workers implementation that uses agents and durable storage. Now, one note on this, one of the requirements, well, there were a little bit of conflicting requirements. It was strongly implied in the requirements that Cloudflare was needed, but it wasn't explicitly mentioned. And then it was also very strongly recommended that HTTP and SSE be used, but Cloudflare doesn't support that. It uses a newer streamable HTTP protocol. So I elected, and this is documented, the decisions, the justifications for this decision. I elected to go with Cloudflare plus streamable HTTP because SSE is deprecated on their end. Oops, let's actually move on with the slides. So human in the loop, I'm going to move through these relatively quickly. Human in the loop is required for things that potentially would be destructive or cost money. And for satellite imagery, obviously, costing money is the primary concern. So what we do is we have explicit gates that require a token to be fetched from Skyfi using their API. Token has a limited time to live. And if the token expires before the human can confirm, then the order won't be placed. Once the order is placed, it has to resend the token, and then the order is executed and the process can continue from there. I believe that Codex here is set up to purchase something, or at least to order something using a zero basis item. So we're going to go ahead and say, I approve. And then the order will have been placed. So the eval harness, and I think I forgot to kick that off. So let me go ahead and kick that off real quick. So the eval harness is designed to primarily focus on the LLM's ordering and use of tools. It's not testing what the LLM is saying in response as much as it's testing that the LLM did certain tool call executions or did not do other tool calls in a specified order. So we prompt the LLM, it runs through a series of cycles, and then we have a deterministic grader at the end that checks tool calls. In the event of a failure, we bump it off to a secondary judge, which will evaluate the inputs, the tools, and then determine whether it was potentially a harness failure or if it was something that the LLM actually got wrong. We have 37 scenarios across 15 suites, so these are defined in here. So these are all of our different scenarios. And that mostly gives us reasonable confidence that the MCP implementation is not particularly buggy and is descriptive enough so that the agent can use them without tripping over themselves. Retirements coverage. Here is the mention that I talked about briefly, streamable HTTP is considered the upgrade over SSE. We do have local hosting. We're supporting conventional ordering. You saw that with codecs. AOI monitoring with webhooks. That ties into the CLI, which I'm going to cover here in just a second for alert persistence. And then there's a full set of integration docs, and the demo agent is what the various Claude and Codex instances are running through behind the scenes. So for the CLI, I did a second project. MCP servers, while very useful, tend to have high token costs because they have to be loaded frequently from the remote server and they have to maintain a lot of context. I think 2025 was really the year of the MCP, but I think 2026 is going to be the year of the CLI. So I've decided to focus a little bit as well on CLI tools. And this is a wrapper over the API. It also serves as the ability to install a system service to poll the Skyfi API endpoints and look for new alerts and notifications that need to be delivered to the user. So there is a Skyfi CLI alerts install method that works on both macOS and Linux, and that is what satisfies the notifications requirement of the project. So moving on back to some of these others, this is Codex, completing things or complaining that there isn't enough budget, even though we've asked it to look for $0 items. Here is Claude running MCP and then returning results for deep research. Here are the evals. I've structured this as a markdown format for human readability. There is a more natural JSON or just limited summary that shows pass-fail. But this explicitly shows all of the different stages of what the assistant is doing and what the grader is doing. So for demo purposes, this is a more useful structure. And we're only running smoke tests right now, but we can run all of the evals that are defined. This is Cloudflare with the durable objects that we have set up so that you can, even though Cloudflare is typically workers are stateless, we can go ahead and maintain MCP sessions just by using the durable objects. And then as far as metrics are concerned, reasonably fast duration. And that's it. That's what I have for my demo. Thanks for watching.